A 1.57 kilogram aluminum strut near a ship's furnace absorbs 2.50 times 10 to the fifth joules of thermal energy. What is the net change in temperature of the strut? The specific heat of aluminum is 910 joules per kilogram Kelvin. Let's begin by illustrating the scenario. We'll sketch the furnace as it's radiating thermal energy in the form of heat. Let's now sketch the aluminum strut. The aluminum strut is placed near the furnace because it's going to be absorbing thermal energy from the furnace. So heat radiates from the furnace and is absorbed by the strut. The strut has mass m, and that mass is equal to 1.57 kilograms. The amount of thermal energy absorbed by the strut is 2.50 times 10 to the fifth joules. Being made of aluminum, the strut's specific heat is equal to 910 joules per kilogram Kelvin. Now, the heat absorbed by an object that undergoes a temperature change is directly proportional to the temperature change, given by heat being equal to the system's mass, its specific heat, and its change in temperature. Isolating the change in temperature delta T, we see that the change in temperature is equal to the ratio of the heat absorbed to the product of the system's mass and its specific heat. Now that we've expressed this as far as we can go algebraically, let's plug in some numbers. The heat Q is 2.5 times 10 to the fifth joules. This is divided by the mass m, which is 1.57 kilograms, and the specific heat of aluminum, which is 910 joules per kilogram Kelvin. Let's do an inline unit check. We see that kilograms cancels with kilograms, joules cancels with joules, leaving us with kelvins, which is the correct unit. So we can now plug this into our calculators to find that the change in temperature of this aluminum strut is 170 Kelvin, which is also equivalent to a change of 170 degrees Celsius.